Hey everybody, this is Patrick Shaka, editor-in-chief of Yachting magazine, and we are here today with Prentice Weathers from IMTRA, and he is also our Sleipner stabilization expert. And today we're going to be taking a look at Sleipner vector fins. So I had the opportunity to speak with Prentice a couple of weeks ago and kind of get the deep dive on vector fins and how they can make your boating better. So we're going to answer all your questions in a little while, but before we do that, we're going to take a look at that chat and learn more about the Sleipner vector fins with IMTRA and Prentice Weathers. So let's take a look. Hey everybody, this is Patrick Shaka, editor-in-chief of Yachting magazine. And today I am here with Prentice Weathers, IMTRA product manager for Sleipner stabilization. And we're here to talk about something very cool today. We are talking about the Sleipner vector fins and how they can take the roll out of your ride. So good morning, Prentice.
Good morning. How are you, Patrick?
Yeah, great to see you today. So I'm excited about this. And full disclaimer, I have had the opportunity to see these fins in action on a few boats, and I've been pretty impressed with the ride. So I'm kind of excited to share this with the people today. So for people who may not know, what is a Sleipner vector fin and kind of how does it work to reduce boat roll?
It's a big question. Sleipner vector fins are similar to other stabilizer fins from other companies that have been around for quite a while. Anybody who doesn't know what a stabilizer fin is can sort of envision two rudders on a boat or a fin on a surfboard or something like that. And they protrude from the underside of the hull. They move side to side. And in the process of doing that, they generate lift, which helps to stabilize the boat. And the way it does that is a process similar to an airplane wing. If you airplane wings develop lift, they're what lift the plane out of the air. And then there are flaps on the wings that control the roll of the airplane. And the function of stabilizer fins is really similar, but obviously you're using the water flow instead of airflow. If you think of a boat moving through the water and these wings or fins sticking perpendicular to the hull, when the angle of attack changes, when the fins rotate, they generate lift and they help correct the boat roll. And without getting further into it, that's essentially the essence of it. So they're essentially, fiberglass, foam-filled fiberglass, and there's a shaft that goes down into the fin that allows the fin to be controlled by a hydraulic actuator, which is inside the boat.
And these fins, they work well underway and at rest.
Yeah, exactly right. And the way they operate, they function differently when they can take advantage of the incredible power of lift from the water flowing over the fin, just like an airplane. Airplane doesn't do anything until you get airflow over the fin. The same is true for the underway function of stabilizer fins. You're using the boat moving through the water to generate lift to correct roll. When the boat is at anchor, it goes into another mode of operation. And this is a seamless transition. You don't push any buttons or anything. It just happens automatically. And the way the fins work when you don't have water flow over them, you're at anchor or you're station holding, is that they use the water as a solid. When the fins push against, fairly quickly against the water, the boat rolls in reaction to that. It rolls opposite from the way the waves are trying to make the boat roll. One way to envision that is to think about sitting in a canoe, and you take your paddle and you put it in the water and you pull the paddle towards you or towards the stern. The water is acting as a solid, and when you do that, you're actually propelling the boat forward. If the water didn't act as a solid, you wouldn't go anywhere. You'd be paddling and the water would be shooting past you and the canoe would be standing still. So if you can think about that, the stabilizer fin pushes against the water, and the boat reacts to that.
So what differentiates a Sleipner vector fin from other types of fin stabilization that's out there?
There are actually surprisingly quite a few differences. The shape is an obvious one. in both planes. When you're looking at it from the side, the vector fin is curved a lot like a surfboard fin, if you will, whereas others are more like a rudder, more rectangular or trapezoidal actually, versus again more like a surfboard wing or something like that. And if you look at the fin from the stern or the bow, you'll notice the real difference, and that is that the vector fins are curved outwards as opposed to all other fins, which are just straight. So that's the primary difference in the fins themselves. There's more to a stabilizer system than just fins. You have to be able to control the fins, to rotate them. And that's done with a hydraulic actuator. At the moment, electric actuators are being developed, but at the moment they're hydraulic. And the difference between the Sleipner, I use Sleipner as an aside here. The company has been known as Side Power forever. They're changing back to the corporate name, which is actually Sleipner. The Sleipner actuators are much more compact than others, and the bearing, so they're a lot smaller, both in height and in some of the other dimensions, but primarily height. Another significant difference is the bearings that are used. Without going into too much detail about all the rest of it, the quality of the bearings is such that the actuators are silent. You can put your ear right up to them while they're operating, and you won't hear a thing. And the service interval is about 4,000 hours before you have to start worrying about possibly changing bearings at that point, as compared to a significantly more frequent service period for others. And then, so we've got fins, we've got the actuator difference. There's also the power pack, the hydraulic power pack, which is quite a compact system. It's virtually all plug and play, and relatively, nothing's easy to install in a boat, but it's quite a sophisticated and compact and well thought out system. And I'd say then the fourth component is the control algorithm, the computer, sensors, the control panel, the algorithms that are used to communicate the instrumentation, which is understanding what the boat is doing, whether it's rolling or yawing or swaying or something like that. All the instrumentation takes the motion of the boat and translates it to communicates it to the algorithm, the computer, which then causes the stabilizer fins to do what they need to do in order to eliminate roll. And that's where a lot of there's science involved in every one of these, but that's actually one of the major differences that people don't necessarily think about. And the Sleipner system, you're able to, in the newer systems as of 2018, you can connect to the Sleipner server and it will download the latest upgrades. And the reason that's important is because there is continuous development being done at Sleipner. They've got 27 engineers or something in the company they're continually trying to make the system better. One of the most recent developments was a self-learning algorithm. So it's able to take the sensor input, tell you what the boat is doing, and it says, the settings that we've used here aren't quite right. We're now understanding, this is the computer talking, understanding what the boat's doing and how it's working, and we're going to tweak it a little bit and make it even better. And those are, one tends to think of vector fin stabilizer systems as being the fins, but there's really a lot more to it, and there's significant differences along the way. And Sleipner is basically an engineering company and really puts a lot of effort, reinvests their proceeds into making everything better. And just looking at the fins, for instance, you'll see a difference. Virtually all other fins are the same design that's been there for 30, 40 years. You look at the Sleipner vector fins and it's really different.
So if we can summarize that, if this sounds right. So we have a shape of the fin which reduces resistance. We have silent operation from the actuator standpoint, also has a low profile, so it's taking up less space inside the boat. We have long service intervals, so you get a lot of life out of it. And what kind of roll reduction?
We aim for 92% roll reduction. And the way you do that is the algorithms I talked about, the sophistication of the programming, but it's really virtually everything to do with the size of the fins and boat speed. Again, we talk about underway stabilization and at anchor stabilization. Just like a gyro needs to be bigger for bigger boats to get better stabilization, fins need to be bigger for bigger boats. So the answer to your question is we aim for 92, even more if we can. The way you do that is to size the fins properly. And every boat is different, different centers of gravity and all this sort of thing, roll characteristics, roll periods. So the objective is to size the fins to give you the most amount of roll reduction in both at anchor and underway. And one of the significant differences, going back to your previous question, between Sleipner vector fins and other fins has to do with this effort to minimize roll, to maximize roll reduction, if you will. And you do that by having larger fins. With every other fin system out there, having larger fins means more drag. You're going to slow the boat down. You're going to increase your fuel requirements, decrease your fuel economy, if you will. The beauty of vector fins is you don't pay a price for going larger. The reason for that is that the vector fins develop lift. The curved shape of the fins and the fact that we tow them out a little bit means that we're generating lift all the time as the boat's going through the water. And that in turn, it physically lifts the boat out of the water, helps it. I'll use the word fly, but that's that's really not fair. But it does lift the boat, generate enough lift to cancel out the drag. So if you were to take a boat that had conventional stabilizer fins from some other company and replace them with vector fins, you'd actually see your boat speed increase and your fuel consumption reduce. So you want bigger fins in order to get your roll reduction to 92, 90, 95% if possible. And the beauty of the vector fins is you're not going to pay a price in terms of drag.
So in terms of talking about size of vector fins, what's the size range of yacht we're talking about where a vector fin makes sense? And does hull shape matter?
Yeah, hull shape does matter. If you were to, let's start with that first. The fins take advantage of the dead rise in the boat. The dead rise is, if you haul the boat out of the water, the bow is really pointy and has very sharp angle from the water line down to the keel. And as you transition aft, it gets flatter and flatter. So if the conventional fins were mounted on the transom, the way the rudders are, and the transom the stern of the boat is horizontal, the standard fins would be pointing straight down, and they'd sort of act like rudders. They really wouldn't be stabilizing very much. But the fact that you're mounting the fins on generally sort of a 19-degree dead rise, it means that the fins are not pointing straight down; they're pointing more outboard. That helps to stabilize the boat. The fact that the vector fins are curved means that we're generating that stabilizing power, that lift, much more vertically. It's almost as if you had a lot more dead rise with vector fins than you do with standard fins. And in terms of boat size, in practice or practicality, sort of 54 feet is about the smallest that they work well on, and vector fins will work very well on a 45-footer, but just not physically enough space to fit all the equipment. So, and then the largest end, about 130 feet with a 2-fin system. Beyond that, 140 feet, 150 feet, you'd need to go to a 4-fin system where you'd actually have 2 fins aft and 2 fins forward.
So obviously, if you're doing a new build, an OEM installation is fairly easy to plan. Right. But for people who are refitting a boat, is this something that can be done as part of a retrofit?
Certainly, most of the business in the U.S. With Sleipner stabilizers is refit business. That's purely because there are not a lot of volume production builders, cruise motor yacht production builders in the U.S. So most of the business that we see here is taking older conventional systems or boats stabilizer systems. They want to upgrade to Sleipner systems, or boats that don't have any stabilization at all. So it's very common. It's obviously, as you say, a lot easier when they have a bare hull to mount all the equipment and build the boat around it. Mm-hmm. In a refit situation, you've got to shoehorn in a lot of equipment into a boat that's already packed full of things. So it's a process. Finding room in a boat, no matter how big it is always a hassle.
There's never enough space on board the boat, no matter what boat you have. That's for sure.
You think a bigger boat, there'd be more space, but there's just more stuff.
There's more stuff. Absolutely. So to that end, I mean, you talk about different fin sizes. So like, what's the range of fins, and like, what's kind of like can we get a cost range of what a project like that could be, like from to?
Yeah, it's a question everybody wants to know, and it's darn near impossible for me to answer. The equipment cost is one thing. The installation cost is another. The installation cost for a new build is minimal. Installation cost for a refit is all over the map. It could be sort of, don't take this as gospel, but you can range anywhere from about 200 hours to install a system, maybe even as much as 400 hours right. to install it. The equipment cost is sort of retail is about $70,000 for a boat in the 60 to 70 foot range. It's about 80,000 for 70 to 80, 90,000 for 80 to 90. So somewhere in that range. But again, installation costs can really be a factor. And when I say the equipment cost, I mean when you buy a stabilizer system, you're getting everything except the hydraulic hoses to connect the components, any brackets you need to support the equipment. Maybe the hydraulic tank needs to be mounted somewhere. You'd make a bracket for that. The electrical components are all included in the equipment cost. So it's really the installation labor, the hydraulic hoses, hydraulic oil, and a little bit of electrical to connect the power source to the from the boat to the system.
Okay, well, I mean, we have a ballpark, right? And again, it's going to depend on the footprint you're starting with, right? Bigger boat, more room, less work to make it work. Smaller boat just takes a little more time. But like I said, having experienced the vector fins on a couple of different boats myself, when we had it off, you could tell, and when we had it on, you could tell. So it was pretty, it was pretty awesome experience to get to see them in action. So for somebody who may be interested in learning more about the Sleipner vector fin, or is thinking about that refit, or is looking at a new build, where could they get more information about the Sleipner vector fins?
A number of places. You can go to impra.com, and you can go from there on to directly see the equipment. There's some articles. There are some articles in Imtra's YouTube channel. You can always call me directly at 508-207-1667, or you can email me at prentice@impra.com. It's PRENTICE at impra.com, or you can talk to any of our distributors. But it's a big subject, and it's for somebody who is unfamiliar with stabilizers. I love talking about them because they're just an awesome product. So.
Yeah, no, I agree. Like I said, it's I've seen what they can do. It's one thing for us to talk about it in theory, but I think when you experience what they can do, I think that's where people go, wow, what a difference. And just hey, listen, just makes a day on the water better, right?
Absolutely, and that's what we're all about.
That's it. That's what we want to do. We make a day on the water better. So Prentice, thank you so much for your insight and expertise. Really appreciate that. And again, hey, this is Patrick Shaka, editor-in-chief of Yachting Magazine. We hope you enjoyed this look at the Sleipner vector fins, and stay tuned for more, because more is coming. And we are back. Prentice, thank you so much for that. That was awesome.
Thank you.
And we are here, and we're back live to answer any of your questions. You can use a little Q&A box down on the bottom right. If you highlight it with your cursor, you should see that. And we have a question from Ross, who tuned in a little bit late, but did have a question. He said, unfortunately, he was a little bit late. He said, Sleipner Vector fins, is this an aftermarket product or is it stock on certain boats or either? So if we could just kind of go back and retell that part of the story there.
Yeah, it's definitely either. As I mentioned in the video, there are not a lot of production motor yacht builders in the 60 plus foot range in the US. So most of our business is in fact retrofit. Matter of fact, I'm in San Diego at the moment, helping install a set of fins on a Bertram 80. That is a retrofit project for sure. And I'll be in Fort Lauderdale next week on a Christensen 124 for sea trials. So there's certainly a lot of refit business, and most of the OEM businesses in the European and Taiwanese and Chinese builders, Ocean Alexander, Sunseeker, Horizon, Ferretti, Riva, etc.
Mm-hmm.
We do supply Viking motor yachts with stabilizers. But there just aren't enough U.S. builders anymore.
Okay. Ross, I hope that helps you. We have another question. Oh, Ross says thank you. Oh, he does have another question. Is this an insurance benefit? You had mentioned about the reduction in roll. Is there any insurance benefit to having a vector fin?
I don't know the answer to that. I don't know enough about insurance to know, but it's certainly going to, the whole objective of stabilizers is not to eliminate roll. That's really hard to do, especially when you're approaching 100%. You'd have to.
Right.
It's impractical, and you're on the water. You could haul the boat, and it wouldn't roll at all. But
right.
There's going to be some motion. The objective of the stabilizers is to eliminate seasickness or reduce it up to very high levels, 98% or something like that. Mm-hmm. It's not really to stop roll altogether. It's to slow it down. It's to control the motion and make your guests feel comfortable.
I think Ross did say he is in the market, so that's why he asked the question. So if you saw Ross, if you missed it, Prentice@imtra.com, Prentice ICE, and you can reach out to him directly. He'll be happy to help you. We have another question from James. Do they interfere with an autopilot? Would the autopilot need to be relearned?
It definitely does not interfere with the autopilot. It actually helps the autopilot. And vector fins in particular are really good at that compared to conventional flat fins, because the vector fins eliminate the sway and yaw influenced by traditional fins as the boat is running through the water. So with vector fins in particular, and stabilizers in general, the autopilot doesn't work as hard. So it's actually a benefit. In terms of relearning, nobody's told me that, and I don't really know the answer, but I suspect you wouldn't need to recalibrate the system.
Okay, James, thank you for that question. We have a question from Terrence. Do they provide zero-speed stabilization? If not, at what speed are they effective at providing stabilization?
Definitely the Sleipner stabilizers are any speed stabilizers. So that's both at anchor and underway. It's a seamless transition. Typically, when you're at anchor and you leave the anchorage at about 3 or 4 knots, the system automatically transitions from at anchor mode to underway mode. And obviously, when you're slowing down to a stop, it transitions at about the same speed. So the vector fins, I just learned this actually. Vector fins were actually developed in response to the at anchor performance of the more conventional straight fins that Sleipner started with. About 10 or 11 years ago, they introduced a straight fin and realized in their testing and all that there's a significant amount of sway, side to side motion, when the fins were operating in at anchor mode. And it's maybe not recognizable when you're standing on the boat. You're not seeing the boat move and the horizon change, but your inner ear is very sensitive to that motion. And it's the quickness of the motion, or the acceleration of that moment that really affects your ear and makes it uncomfortable. And so, being a really clever guy, Ronnie Scowen, the president of the company, they're all boaters over there, and spent a lot of time on the water testing these straight fins. And they said, that's an uncomfortable motion. What can we do to change it? And that's actually how the vector fin, the curved fin, was developed in response to the ad anchor characteristics. So that's a long answer to say, definitely do both ad anchor and underway.
Let's see what we have here. I think you may have partially answered this. I have another company's underway only. Can I convert them to vector fins?
Yes, a lot of our refit business is actually removing the underway only stabilizers from made by other manufacturers that have been on the boat for X number of years, and replacing them with Sleipner any speed stabilizers. So it's not as simple as just pulling the old fins off and putting new fins on. It's really has to be seen as a more complete replacement, where you're removing the fins, removing the actuators, and replacing them with larger fins and larger actuators. The rest of the system, the hydraulic tank, may be reusable if you have engine PTO pumps, which you do because you have underway only. We can reuse those, or it. And the bigger challenge is taking a smaller underway only actuator and replacing it with a larger any speed actuator. And what I mean by that, if you didn't pick it up from the video, was that size matters. When you're at anchor, you don't have the advantage of the incredible power of water flowing over the fin. You're going into the at anchor mode, and in order to get really good stabilization, you have to have a larger fin than you would for underway only. So it's definitely doable. I'd say 90% of the business that we do is replacing old underway only systems with our systems, and that's tremendous benefit.
All right, Terrence is back with a follow-up. Thank you, Terrence. When discussing hull shape, what hull shape or shapes are most effective? Are they most effective for round, deep V, semi-displacement, etc.?
They are effective on all, and it doesn't really matter what hull shape you have. The fins are effective on all of them. And actually, a sailboat hull, if you will, a really round hull, is a lot easier to stabilize than a flat hull, which to me was sort of counterintuitive because I grew up sailing. That was my life, and I know sailboats go do rock and roll like crazy. So it seemed to me intuitively that they would be harder to stabilize, but in fact, the opposite is true. And if you think about a boat with a really flat aft section, they are harder to stabilize. And the reason for that is that, and this is particularly true once you get up on a plane, there's a huge difference between a trawler, which operates, sort of displacement speed mode, if you will, displacement speeds, which is 8 or 9 knots and lower. When you're talking about a displacement, a planing boat, a boat that gets up on a plane when you hit around typically 10 or 11 knots in a lot of boats. And most modern motor yachts are planing boats. The behavior of the boat on the water really makes a big transition once you get up over the hump and onto a plane. The boat becomes much stiffer. And by that, I mean it wants to hug the face of the water a lot more than when you're in slow speed. And that makes it harder to stabilize. Again, a little bit counterintuitive. You would think, okay, a stiffer boat is going to be, less rolly, easier to stabilize. The fact is that the boat, when it gets up into higher speeds, wants to hug the water. The problem is that the water's moving. The water's doing that, so the boat's gonna want to stick on the face of the wave, and convincing it to not stick, not roll with the wave is hard to do. So hull shape matters, but We just simply need to get an idea of what kind of boat it is. We have a huge, there are 1,500, 2,000 of these systems out there. So we've got a huge bank of knowledge, but we have a form that could be filled out that would tell us all the data, the characteristics of the boat, and we can match the stabilizers to that.
Okay, we have a couple more really good questions here. I have a gyro stabilizer installed in my boat already. It's great at anchor, but not so much underway. Could I add a vector fin system as well?
Absolutely. Gyros and fins complement each other pretty well. They're both trying to do the same thing. They're both trying to stabilize the boat, and the characteristics of a gyro are such that they're really good at anchor. But once you get up and in displacement modes, before you get up onto a plane, and for the reasons I just mentioned earlier, once you get up on a plane, you need more power to keep the boat level and not have it roll. And a gyro has a fixed amount of power. A Seakeeper or a Quick or anything, the size of the gyro is specified as their the amount of force, stabilizing force that they have, and that's all the power they have. They won't generate more. So just when you get up on a plane and you need more stabilizing power, unless you've got a whopping big gyro, then their ability to stabilize the boat diminishes rapidly. At the same time, fins, however, are just hitting their stride. The faster you go, the more power you get from the fins. So it's actually the transition from displacement mode to planing mode is just about the time where gyros lose effectiveness and fins gain effectiveness.
Okay, we have some more questions. Oh, great. You had mentioned 90 to 92% roll reduction from the fins. Why can't you get 100%?
In anything in life, trying to get that last 2 or 3% becomes really, really difficult and very, very expensive. You can get pretty close to 100% if you have really, really big fins, maybe 4 fins instead of 2, really big actuators, tons of power to drive it all. But it's just diminishing returns. Again, we're not really trying to eliminate roll. We're trying to eliminate seasickness. And you can accomplish that without eliminating roll altogether in a much more cost-effective and reasonable manner.
Right.
Just don't get, if you're not getting sick, then a little bit of roll is, you're on the water.
Yeah, I hear you. All right. Terrence, thank you again. Is another great question. Do they have a negative impact or any impact on directional steering in various sea states, following, beam, and the like?
Really good question. The vector fins really stand out compared to conventional fins, and definitely compared to a gyro in following seas, which is an important characteristic of the fins. They do a superb job in underway stabilization in following seas, quartering seas. The design of the fins in general, the curve eliminates sway and yaw up to 50-55% compared to conventional straight fins. The position of the fins fore and aft on the hull has an impact on their steering effectiveness, or a steering effect, I should say. We want to make sure that when we install vector fins, they're aft of the longitudinal center of gravity, which is somewhere aft of the center line of the water line, fore and aft. And if you move them farther forward, you can create a steering effect that's undesirable. Because vector fins, due to their shape, develop lift, we want to move the fins farther aft and develop that lift in the back part of the boat, which helps lift the stern and push the bow down a little bit, just like a trim tab or interceptors would do. So you're getting a secondary benefit of eliminating steering influence while also physically lifting the boat. I mean, some of the fins will generate up to 3,000 pounds of lift, which is pretty amazing.
Guys, been asking great questions. Thank you so much. I have one more here I see. And let's see, does Sleipner make an electric stabilizer?
Not yet. They actually have made some in development. And believe it or not, there are two factors. The reason they're not here right now. One is the supply chain issues that we're having, microprocessors in particular. And the other reason is that it's a more challenging job to develop electric actuators for vector fins than it is for conventional straight fins. And the reason for that is the vector fins have the secondary benefit of lift, lifting the hull. So the electric actuators need to hold the fin at under load very differently than the way electric actuators do for straight fins. Hydraulics are awesome at holding high loads, forever. With electric, it's actually more of a challenge because you have to apply power to the actuator to hold that attitude. But Sleipner is on the final stretch in getting those developed, so we should see them next year.
Well, the awesome questions just keep coming. I have another one. What propulsion system or systems do they work best with? Straight shaft, IPS, water jet, stern drive, and what do they not work with? Are there any?
They work well with all drive systems except potentially jet drives. The Ocean Alexander 70s, for instance, which were built in Florida for while they were built, use Volvo pods, and they're awesome. Conventional straight fins, Z drives, whatever you have, it makes no difference. The key is to position the fins on the boat so that the wake of the fins is not in line with the props. You don't want to disturb water going to the props, but that's so easy to do. It's almost not worth mentioning. Jet drives, however, if the fins are positioned in such a way that they interfere with the intake of the water into the jet drive, that's undesirable and something to be avoided. It's not to say that fins won't work with jet drives. It's just that you have to be much more sensitive to placement of the fins.
Whew, those are some great questions. And I'd like to thank you, Prentice, for being with us today. I'd like to thank
My pleasure.
Thank you. I'd like to thank you all the participants who stayed on with us and viewed the webinar and asked these amazing and awesome questions. If there's anything you want to follow up, again, it's Prentice, ICE@imtra.com if you want to follow up with him after. And this will also be hosted at yachtingmagazine.com if you want to do a review at any point. And again, Prentice, thank you very much for your time. We really learned a lot today. And this is Patrick Shaka, editor-in-chief of Yachting Magazine, signing off for now. But again, stay tuned for more because more is always coming.